Bone marrow aspiration and biopsy is basically taking a sample of the bone marrow for diagnostic purposes. This is most commonly done from the back of the hip, what's called the iliac crest. The aspirate is the liquid part of the bone marrow, and the biopsy, also known as a core biopsy or a trephine biopsy, is removing a bit of solid bone marrow with the needle. The goal is to get several teaspoons worth of liquid marrow in a small sliver of the solid bone marrow so that it can be sent to a laboratory for testing. The current procedure involves local anesthesia with the stylet featuring a razor-sharp edge inserted into the hollow needle. The surgeon, gripping the handle with one hand, exerts force to turn the needle, navigating it through the patient's bone. Once reaching the cortical bone, the cap is unscrewed, revealing the hollow needle. The needle undergoes further rotation to carve out a small piece of bone marrow, requiring precision to avoid compromising the marrow. It is important to note that the current one-handed grip of the device is uncomfortable and takes a toll on the wrist and shoulder of the physicians doing the procedure. The goal of my project was to create a more ergonomic handle to alleviate the physical strain on surgeons, as well as to design a functionally stable handle to minimize unsuccessful sampling attempts. I started by creating a mood board, taking inspiration from various products used in everyday life like the steering wheel, extruders used in the kitchen, bike handles and pressure pumps. Next, I put my ideas moving by sketching the shapes I had in my mind into my sketchbook. My approach was to rethink the handle design, opting for a two-handed design over the conventional one-handed grip. Using Fusion, I brought my ideas to life and explored various possibilities. And with that, I finally designed my prototype for a two-handed grip. This two-handed design shall allow users to apply force with both hands, facilitating easier bone penetration. Additionally, it shall allow stable, symmetric application of force, ensuring that the needle remains in a straight line. To validate my design, I conducted a draft analysis of the biopsy handle on Fusion to identify potential issues and made design changes accordingly. I also verified the feasibility of my device through a FEA simulation. I increased the thickness in the central part of my device while playing with a range of materials like Bayblend, nylon and silicone. I decided to go with Bayblend as it is both economic and durable. The labor burden calculation estimated the manufacturing cost at $19.6 per unit, which is well below the current products available in the market. The market for bone marrow aspiration and biopsy needles is expanding due to a growing need for diagnostic purposes, driven by an increasing demand for innovation in the sector.